Alright guys, so I'm going to get us started with an introduction to quadratics. If you go to Google Classroom, you can find this under classwork, and it is labeled 6-0. You'll find a link to Desmos. That's going to open up the website student.desmos.com, and then you're going to type in the code P97YGW. So clicking on the link, it should already be there, but go ahead and click join. And then we're going to log in if you need to, and you're going to see this screen pop up. So what we're looking at is, in order to get started, we have to understand that there's different functions and they have different shapes. We've covered and mastered the concept of a linear function. So clicking on that turns on the idea of a linear function, and we see a straight line. It has a constant rate of change. The m value, the slope, dictates the steepness of the line, and the b value, or the y-intercept, dictates where it crosses the y-axis. In this unit, we're going to cover the shape of a parabola. A parabola is a quadratic equation, and a lot of the time we're going to be spending in this unit is solving a quadratic equation or looking at quadratic function. The solution to a quadratic function is the point in which where it crosses the x-axis. So right here, we think of this as almost like the ground, and we're looking for where the parabola crosses in those locations. So this would be one solution, or what we call the root. So I like to think about it as like if this was the ground, we would pull it up from its roots, or a plant up from its roots. And those root values are the solutions to the quadratic equation. And I can change functions of the way that the quadratic equation changes. So looking at it, and this is in standard form, ax squared plus bx plus c, which we saw a lot when we were dealing with polynomials. It has the degree of 2. And as I change that a value, it changes the width of the parabola. So as you see, when it becomes negative, the direction of the parabola is down, and when it becomes positive, the direction of the parabola takes on like a bowl shape. So it is a curve, and as we change that, it widens it and makes it thinner, and then it also flips over when negative. If I change the c value, again in standard form, this is this value right here, it changes the y-intercept, or where the parabola crosses the y-axis. So changing these variables can change the way the parabola looks. A lot of things we deal with in our reality take on this parabolic shape. For instance, anything I throw up in the air, for instance, a basketball, I would see it take on this parabolic shape. One really cool feature of a parabola is it's symmetrical. So right now the y-axis serves as a line of symmetry, meaning that any point on the left side with a negative x is the same exact point on the right side with a positive x. So it's perfectly symmetrical. So again, as I change that, I can change the way the parabola looks. So as you see the x value is changing, my roots are changing. The point in where it crosses the x-axis is changing, and that's really what we're solving for, is where does the parabola cross the x-axis, or what are the roots of the quadratic equation. Some other functions we've already discussed, but just to familiarize ourselves with, is exponential functions, which we saw this year. It doesn't touch 0, even though it might look like it, and then it rapidly grows. One neat thing I want to show you with exponential functions is currently we're dealing with the coronavirus, and this is a great post on the Washington Post website, so it's really cool to take a look at. And they talk about how the spread of this disease does take on that function. So we see these functions in the real world, and here we have an exponential growth showing right here in the United States of our coronavirus spread. And then as you come down here, and I encourage you to check this out, it shows how the spread of the coronavirus is affecting our society. And what's really cool is it shows you animations of why flattening the curve, why we're currently not in school. So for instance, this is if we were all moving around in society, interacting with each other. It measures how many people are healthy to sick and how many people recover, and then it shows you the exponential curve increasing as well as getting healthier decreasing. So then I move down if we were to, for instance, quarantine. So on the left side, these are people that are forced to be quarantined. And then as I slowly open up that quarantine, it shows that over time less people are getting sick, but it still eventually will spread. And so again, we see the exponential curve, but it's not as drastic, and then eventually everyone does get healthier. And then the next one is, and some of those dots are not moving, so this is what we call social distancing, staying away from interacting with people. And again, it shows the exponential function over time, and you see that curve of the exponential function flattening out. And then what we're currently dealing with in our society is extreme social distancing, and that's very little people interacting and staying home. And that really is the goal. And so I know that this distance learning might be challenging for some of us, but the real goal is, mathematically speaking, we're trying to flatten that exponential curve from passing its threshold and trying to keep as many people healthy as possible. So this is a cool website that I'll link on Google Classroom to check out. So back to the function families, some other functions that we've looked at is absolute value functions, so we've studied that. We haven't really talked a lot about this, but square root functions, a cubic function, reciprocal functions you'll master in higher grade levels. A piecewise function, we've talked about piecewise functions, but this is an example of a piecewise function that has a piece of a quadratic function mixed with a piece of a linear function. So this piece is quadratic through a certain domain, and then this piece is linear through a certain domain. And then finally, trigonomic functions, which is the study of curves, and that you will cover in Algebra 2 trigonometry. So as I mentioned, in this unit, we're really going to focus on this shape, the parabola and the quadratic function. And our main goal is to figure out what are the x values, what values does the parabola cross the x-axis. So this example would have a solution of -2 as well as a second solution of +2. So we often get two solutions. So this is a parabola that has two solutions. However, we can also have just one solution. For instance, this parabola is only touching the axis one time, and so therefore it has one solution of 0. And so I can have one solution. I can also have no solution. If this parabola does not ever touch the x-axis, that would have no solution. So in our first unit, 6-1, we are going to take a look at solving quadratics using factoring, which is what we mastered in our last unit. So I just want to finish up this lesson by taking a look at an application. So basketball is an example of something that takes on the parabolic curve. So this is looking at the quadratic equation in what we call vertex form, and we'll cover that later on in this unit. But this is really the same thing as ax squared plus bx plus c, using different variables and set up in a different format. And so as I change the variables, I'm trying to align it with this current shot that this person is taking. So I'm trying to get the y-axis to, or excuse me, the y-intercept to be equal to where I think his ball would be released from his hand. And then if you are doing this activity, just play around with it a little bit and see if you can line it up to predict whether or not he would make the shot. So I'm just going to play with this a little bit. It's pretty aligned. And my prediction would be that he will probably miss this shot. So here we have a video just to kind of show you, and I know it's kind of a teaser because we don't have an NBA season or an NCAA season, but feel free to take a look at any old videos of basketball games and look for that quadratic curve.
Just like that, on the 360.
All right, and then another video I wanted to show you, another application of where we see quadratics is the famous game of Angry Birds. So again, you'll see that parabolic curve. So there you have it, some activities to play around with and familiarize yourself with the shape of a quadratic. We'll take a look at lesson 6-1, how to solve by factoring, and then we will continue on this unit. I appreciate you